Welcome. In this webinar, we're going to look at Orkestra, which is MPSTOR's data center operating system. Orkestra is built for OpenStack, so it integrates a number of OpenStack components as well as MPSTOR's proprietary technology. The goal of Orkestra is to deliver operation efficiency to the cloud service provider. We hope you enjoy it. If we look at the challenges in building a cloud service, you can see that the NIST.gov website lists out a number of challenges, such as rapid elasticity, measured service, on-demand self-service, etc. And if we look at the status quo, not all of those challenges are met. But with Orkestra, we've improved upon the status quo. So on the issue of rapid elasticity, we allow independent virtual machine and storage sizing for that virtual machine by using our automated SAN storage provisioning. In terms of measured service, Orkestra has a fairly comprehensive common management database which collects all of the statistics for the data center, for all the data center stakeholders. For on-demand self-service, the lack of automation in many products has some pretty tough effects for the data center, but Orkestra uses an automated storage farm called ProVizo. So ProVizo is built upon the principles of automation and federation, which reduce greatly the data center operational expenditure cost. The storage stack used by Orkestra is based on MPStackwareᴶ, and that provides quite a lot of features for resource pooling and multi-tenancy. So what is Orkestra? Orkestra is a set of tools built around OpenStack to manage a private or a public cloud. And the key components of Orkestra are ProVizo, which is an automated scale-out provisioning system, MPStackwareᴶ, which is a full-featured storage stack, which runs on any x86 compatible system, a set of data center management tools, and tools that wrap around OpenStack to make it easy for the data center to deliver an infrastructure as a service solution. So one of the problems that you see in delivering virtual machines to end users is the pizza slice problem, whereby if a user decides that he wants to use a certain amount of core and CPU and a certain amount of disk in an integrated server storage box, he pretty soon finds that one of the resources will be completely used up. So in this case of two VMs, both using a large amount of disk, you can see that there's quite a bit of core and memory wastage. So typically what providers do is they give a pizza slice, a slice of the box to a user. And that way there is no wastage. However, the user does wind up having to take a virtual machine that's perhaps not right-sized for his application. So integrated service storage has two problems. One, if you pick any slice, then the service provider is going to have waste. And if you force the user to have a pizza slice, then the end user will have waste because his virtual machine may not be right-sized for his application. So you need a better solution. The better solution is all around, or centers around a provisioning challenge. And what MPSTOR has done is we reduce that operational expenditure by automating provisioning in the data center. And we reduce the capital expenditure by making sure that our storage operating system, MPStackwareᴶ, can run on any x86 box. So more automation means lower cost, more control over your services, how you deliver them. So the solution consists of splitting the infrastructure into compute nodes and storage nodes, implementing an automation engine sitting on top of the storage nodes. That automation engine's role is to collect any storage that you add to the system completely automatically. The compute nodes can then make a request for storage. So this isn't an administrator pushing out a volume. It's the compute nodes requesting storage. That storage is then provisioned and returned back to the compute node, and when it's returned, the compute node knows where to access it, how to access it, and what credentials it needs to access it. That storage could be provisioned over iSCSI, over Fibre Channel SAN, over SAS SAN, over InfiniBand, whatever back-end storage SAN that you have. So if you can do that for one, then you can scale it out, obviously, to many compute nodes and many storage nodes. And not only that, but you can right size your VM, set your VM to whatever number of cores and whatever amount of memory it needs, and right size your storage to whatever storage size you need. So this is one of the main benefits of splitting compute nodes and storage nodes into two pieces of infrastructure. You can allocate independently your VM and your storage. If the storage farm needs more storage, well, then you just plug it in. By virtually plugging in the storage gets added to the storage pool of the automation engine. So it's clearly a scale-out solution. Just plug it in and it gets added. And this gives a number of benefits. So the benefits of automation are to the end user. He's able to have his project sized correctly. So he can have small VM and a large amount of storage, or a large VM and a small amount of storage. Not only that, there's an additional benefit in that you can set the service level agreement of the virtual machine infrastructure and the storage infrastructure. This is a point that we'll come back to further in the presentation. The benefits of service provider are that there's lower OPEX because he has automation, analytics, lower management costs, and he's lower CAPEX because he's using off-the-shelf hardware for the storage without any loss of functionality. And MPStackwareᴀᴹ runs on any x86 box. So what is ProVizo? So ProVizo is a scale-out storage solution. So for delivering infrastructure as a service. So it allows us to add more nodes on either side, compute or storage. Just add them in. ProVizo will manage that. ProVizo also understands the concept of infrastructure tiers. So I can set my tiers up as gold, silver, bronze. I can then understand the requests from those various tiers and then provision the storage accordingly. This is a great benefit in setting service level agreements. You could have a gold service level agreement, and people who would provision from that tier would get gold quality and silver and bronze accordingly. So what does this mean to a service provider? Service provider can now provide a flexible set of products ranging from low cost to higher cost. Those products will run in different type of compute groups, such as a gold, silver, bronze compute group. Those compute groups would use different storage groups, and we can set up logical mappings between the bronze, silver, and gold compute groups with the Orkestra tools. And behind those groups are real pieces of infrastructure, which would range from GigE, iSCSI SANs, all the way to Fibre Channel or SAS solid-state disks. And that's all of the type of infrastructure that Orkestra can manage. So practically, if we then have users who are going to request products from one of those categories, such as a bronze, then the Orkestra toolkit will just dispatch that virtual machine to the bronze infrastructure and create the storage in that bronze category storage. And the same for gold, and the same for whatever user request. And we can see here that not only are the volumes and the virtual machines right sized, but also the service level agreement is appropriate to whether it's a gold, silver, or bronze product that the provider is selling. So Orkestra in the actual data center when it's being deployed can be deployed in a number of different configurations. A very simple one is an all-in-one configuration, 2 some-in-one, or 1-in-1. So 1-in-1 would be a production type environment where a data center is offering infrastructure as a service in a utility cloud model. An all-in-one might be a very simple private cloud, publicly hosted. So this is what an all-in-one configuration looks like. Minimal hardware, a lot of storage functions and cloud functions combined into one system. Some-in-one configuration would have computes split out as independent. And one-in-one configuration has all of the storage functions split out into individual units. Additional parts of the Orkestra package are the service provider portal. This is a provider portal that's just part of the package to help service providers get up quickly with a user-facing portal. That user-facing portal allows the user to configure his virtual machine, and unlike the opposition or unlike the competition, you can select your core, your storage, and your operating system. All of these can be selected independently, and you have additional features such as backup, snapshot, and replication as part of the package. The user also has his own dashboard, so this is quite similar to the OpenStack dashboard, except it has been enhanced with features that aren't available in standard OpenStack. MPSTOR has enhanced this with additional features for the user. In terms of the data center tools, there's a set of data center tools that allow the provider to set up and manage the Orkestra installation. So there's an admin portal, and that's for the data center to manage and view his cloud. A tool for setting up racks and which systems are installed in which racks. The configurator that's used to set up the compute and storage group relationships that we looked at earlier, the relationships of gold, silver, bronze, and the CMDB browser. So a lot of information about the logical and physical topology of the data center is captured in the CMDB browser, and all of that can be viewed and browsed. So this is an example of where we're browsing a compute group, and we're looking at the storage that's associated with that compute group and the various storage nodes in the storage group. And we can continue to drill down, and the data center manager can drill down into the storage node and pull up the storage node. So he has a single pane of management from within his CMDB viewer. So in conclusion, what does Orkestra provide? It provides an OpenStack installer using an all-in-one, a sum-in-one, a one-in-one configuration. It provides an automation tool, ProVizo, which is the scale-out storage farm manager. As part of the ProVizo, there is an extended virtual machine scheduler for OpenStack, so that the virtual machine can be launched in the correct server infrastructure. This is an extension of OpenStack. There's MPStackwareᴀᴹ storage array. So this is a full-featured storage array allowing management of a very large number of disks and a lot of storage features such as replication, snapshot, volume virtualization. This storage software runs on any x86 box. There is a set of data center management tools to allow you to do customer management and OpenStack project management. There's the single pane of management for browsing the entire topology and looking at all of the analytics of the data center. There's the project usage tracking for billing. And then finally, there's the end user portal to allow the end user to manage his virtual machines and storage, and the service provider portal. And with that, there's also an e-commerce sample site.
So, thank you very much for listening. And if you'd like to learn a little bit more about Orkestra, please visit the MPSTOR website at mpstor.com/Orkestra.